All right, 2019 AP Calc number 6. So this is infinite series. They give you some n's with the derivatives, f second derivative, third derivative, fourth derivative, which you don't think you need, but you will need later. And then this is f of x, and this is f prime of 0. Yeah, that's fair to say. F prime of 0, which is -2. Now, I would never do the problem this way. I'm just setting you up for where I'm going because I have to do this on a couple sheets of paper. So keep that in mind. I got to scroll down. Well, actually, I guess I don't. Yes, I will. Here's a function, all blah 0, right third degree Taylor normal at x equals 0. So the third degree Taylor polynomial would be f of 0 plus f prime of 0 x plus f double prime of 0 x squared over 2 factorial plus f triple prime of 0 x to the third over 3 factorial, which is pretty quickly done. 3, that's the initial term. That's this point right here. Plus -2x plus 3x squared over 2. What about 2 factorial? Well, the 2 is minus 23 over 2, which is 23 over 2 times 12, 23 over 12 x to the third. I believe that's 2 points, but check your answer key. Part B. Write the first three non-zero terms for e to the x. First three non-zero, got it. And then write the second degree. Notice we have a third degree here for e to the x times f of x. So that's 1 plus x squared over 2 times, I only need the first three terms. 3 minus 2x plus 3x squared over 2. And even here, I got to be careful I don't waste time. They just want the second degree Taylor polynomial. So I need all of these. 3 minus 2x plus 3x squared over, goodness gracious, 2. Then I need these plus 3x minus 2x squared. I don't need the last one. And then I just need the first one plus 3x squared over 2. So I did this, and then I did these, because this is going to give me x to the third, and there's no point. Add them up. E to the x, f of x equals 3 plus x. This is 1.5 plus 1.5 is 3 minus 2 is plus x squared, which I feel is wrong. I got to think this one through for a second. Yes, plus x squared. We're rolling right along. Okay, let h be the function defined by the integral of f of t, and use this part a1. So we got to use this whole thing to find h of 1. Now I did this where I just took the integral and plugged in 1 after the fact. They do it a slightly different way. So c, let's write it all out. H of 1 equals integral from 0 to 1. This bothers me. I don't say anything about what's going on at 0. And the hard part, remembering to put in the dummy variable. because if this was x, then off we'd go. So h of 1, integral 0 to 1, 3 minus 2x plus 3 halves. See, I forgot already. T squared minus 23 over 12, t to the third. For those who are terrified of forgetting the dummy variable, I think if you put in an x, you'd be fine. But I'm the teacher, I'm supposed to do things correctly, supposed to being the key word there. Integrate 3t minus 2t squared over 2 is t squared plus 2 to the third over 2 minus 23 t to the fourth over 48, 0 to 1. So 0 is going to vanish, and we're left with 3 minus 1 plus 1/2 minus 23 over 48, which is 2 plus 1/2, which is 5/2, minus 23 over 48. Multiplied by 24 over 24. By the way, you would be fine just writing that, but I'm a math geek, can't do it. 5 times 4 is 20, 120 minus 23 is 97/48. Flick. Okay, and last but not least, knows it converges. That means it's constantly getting smaller. It knows it alternates, so I can use the alternating series bound, blah, 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 blah. So they do this very quickly, like it's easy. I don't think it's so easy. First things first, let's look at this term right here. We need the next term, right? So need next term for f. All right, so here it is, 23 over 12. All right, 54 is the next derivative. So let's get all the way down here. 54 times x to the fourth over 4 times 3 times 2 times 1. And only do that to make it easier to simplify. 9x to the fourth over 4, but we do this silly thing. Goodness gracious, I can never remember how to do this. Let's just do this. Next term for h would be add 5, 9x to the fifth over 20. And then we would say the maximum error equals absolute value of 9 times 1 to the fifth over 20, which is less than or equal to 0.45. Tricky stuff. Good luck.